Hello and welcome to helpyourmath.com. In this video, we are going to look at examples of finding the measures of central tendency of a data set. The measures of central tendency are just fancy words for mean, median, and mode. Before we look at the examples, let's just review what those measures of central tendency are. To calculate the mean, that means we're finding the average of the data values. To do this, we will add up all the given values and divide by the number of values in the set. The median is the middle number of the data set. To find the median, we will arrange the data values from least to greatest. Cross out the least and greatest values until you've reached that middle portion. If you have an odd number of values in the data set, there will be one number in the middle, and that will be the median. If there are an even number of values in the data set, there will be two numbers in the middle. To find the median, we're going to take their average. That means we're going to add them up and divide by 2. Again, average is the same word for mean, so it's like we're taking the mean to find the median, which is a little bit wonky. Last, we have the mode. The mode is the number or numbers that appear the most frequently in the set. The funny thing is that a data set can have no mode, it can have one mode, two modes, which is called bimodal, or more than two modes. So there can be all different sorts of combinations of modes that we'll see. Let's look at some examples. In our first example, we want to calculate the measures of central tendency for the number of jumping jacks students from a physical education class completed in 60 seconds. And before we get started, to calculate the mean, we are going to have to add up all of these numbers. I suggest having a calculator. So if you need to pause the video to go get a calculator, do so now. Okay, you have your calculator, or are you going to do some mental math? Because mental math is good too. All right, to calculate the mean, we need to add up these numbers. So we have to add up 35 plus 45 plus 38, blah, 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 plus 35. When I added these all together, I ended up with 428. And then we're going to divide by the number of numbers in the set. So how many numbers do we see? 1, 2, 3, 4, 5, 6, 7, 8, 9. This indicates there were 9 students participating in the jumping jack 60-second off. So we're going to divide by 9. And when we do this, we end up getting a decimal. I think it's like 47.555555. If you want to round to the nearest jumping jack, that probably makes sense because we don't, even if you're in the middle of a jumping jack when the teacher calls time, you don't count that as like, well, I was 4/10 the way through it. No, we would either just not count it or round it up. Because the 5 is in the 10th place, I'm going to bump it up and say the mean was 48 jumping jacks in 60 seconds. To calculate the median, we want to line up these 9 numbers in order from least to greatest. Since there are 9 numbers and 9 is an odd number, I am expecting just one number in the middle. I'm going to start with that 30, and I'm going to cross it off as I go. Then I have a 35 and a second 35. So already I know we at least have one mode. We have a 38, 40, 45, 65, and 2 70s. 65, 70, and 70. Okay, so to calculate the median, I'm just going to cross these off so it's not those. Next extremes, next, next. And I see 40 is right there in the middle. There's 4 on the left of it and 4 on the right of it. The median is 40. Lastly, to calculate the mode, did we see one or more numbers that repeated more than once? I remember writing 35 twice, right? That repeated twice. And 70 repeated twice. So this one is bimodal. We have 2 modes of 35 and 70. So to summarize our data, I'm just going to go over here and just write everything all neat so I can just put a box around it. The mean we calculated to be about 48 jumping jacks in 60 seconds. The median we found was 40. And this was a bimodal. We have 2 modes of 35 and 70. So that would be the measures of central tendency for this first example. So far, so good? Let's do another one. Here we want to calculate the measures of central tendency for the age at which math professors at a community college earned their doctoral degree. Again, I strongly suggest having a calculator out. And we also want to make sure when we're calculating the mean, it's very easy when you're using a calculator to have a typo, right? To put a 2 instead of a 29, or to put 229 because you hit the button twice by accident. So we want to make sure when we're calculating the mean that it does make sense, right? If I'm calculating the mean of these numbers and I somehow get 54, well, that's not good because the largest number in my set isn't even 54. So that indicates to me that I made some sort of computational error. I might want to go back and check my work. So to calculate the mean, I'm going to add up all of these numbers. When I added up all these numbers, I ended up with 542. And how many professors were there? Well, there was 2, 4, 6, 8, 10, 12, 14, a total of 16. So I want to divide by 16. And again, I'll round to the nearest year. I'm not going to do partial years here. When I do this division, I end up with about 34. So 34 years is about the mean for this data set. Next, we want to find the median. I'm going to need a lot of space for this because there are 16 values that I need to put in order. So I'm going to squish it all the way over there. And let's start with the 20s. So I see a 26 and a 26, a 29. Okay, so two 26s, 26, 26, 29, 29. How about, I'm going to cross those out so I don't use them again. Okay, now I see two 30s right there, so that's nice. They're right next to each other. A 32 right here, 32. Then I have 1, 2, 3 35s, 35 and 35. Then there's two 30. Oh, wait. There's a 37 before those two 38s. So 1 37, two 38s, 37, 38, 38. Then I have 40 and two 41s. Ooh, I am going to get it to squish these all in. Okay, so there are all the numbers. Because there were a lot of them, I'm just going to double check that I really have 16 numbers here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I did count 16. So now I'm also expecting there to be two numbers in the middle. So if I do this or if I go to calculate the median and there's only one number in the middle, I might have left a number out. So it's a nice little check for us. Going to cross out. There's 3. Here's 4, 5, 6, 7. Aha, there are the two in the middle. They're 35s. I don't need to average them. I know the average of the same number is just going to be that number. So the median is 35. Last, we want to look at the mode. So the mode, is there one number that occurs more frequently than all the rest? There's two 26s, two 29s, but there are 3 35s. I don't think any other number repeats 3 times. So 35 is our only mode. This particular data set has one mode, and that one mode is 35. These data values, these measures of central tendency are much more compact than the previous example, aren't they? They're really close to each other. So just to rewrite everything, the mean for this particular set was 34, roughly. The median and the mode were both 35. The median was 35 and the mode was 35. Okay, still good? We're going to do one more example, but this example is going to look a little bit different than what we've seen in these past two examples. I have it set up where I show the frequencies instead of writing all the numbers out. We can work with the frequencies, or you can list all of the numbers. I'll show you how to use the frequencies because I trust that you can, well, I'll talk about how you can line these numbers up. But let's see what we're looking at in this example. Calculate the measures of central tendency for the scores students in a chemistry class earned on their ACT. So we have 5 different scores, and the frequency just means that many students scored that score. So 2 students got 24s, which means this would be 24 and 24. So that's representing 2 students. 4 students scored a 25, so we would write 25 4 times. You see what I'm doing here? So that this would be listing it out if you want to list it out, but I'm going to use the frequencies instead. Feel free to list it out if you're more comfortable. I'm just super lazy and I don't feel like listing out 26 8 times. So to calculate the mean, now to calculate the mean, what we need to do is add up all of the values. So in your calculator, you can do 24 plus 24 and 4 25s, so 25 plus 25 plus 25 plus 25 and 8 26s. Or because these numbers repeat and repeated addition is multiplication, we could calculate the mean by saying it's going to be 24 2 times plus 25 4 times plus 26 8 times plus 29 3 times. And then I can just do 31 since there's only one. If you want to do 31 times 1, that's fine. You see what I did there? Instead of doing each addition separately, I use the fact that multiplication is repeated addition to kind of simplify this a little bit, or at least to make it shorter. Now, what am I dividing by? How many students were in this chemistry class? Well, that would be the total in the frequency. So we want to add up the frequencies. 2 plus 4 plus 8 plus 3 plus 1, that's a total of 18. So this particular class has 18 students in it. And what I should see up here is if I look at the frequencies, that should also add up to 18, which it does. So when we do this addition and multiplication, we end up with 474. 474 divided by 18 gives us, and again, I'm going to round because the ACT is only measured in units. We end up with 26. 26 makes sense, right? Because the scores for the ACT were 24, 25, 26, 29, and 31. So it makes sense that the mean would be 26. How we doing? You okay? You're doing great. Okay, next to calculate the median. And again, rather than putting everything in order, I'm going to use the frequencies to help me. So one thing I mentioned in the video on medians is that if you want to find the median, you can actually use a formula. In this case, we know there are 18 students, so we know we're actually going to have to add 2 values and divide by 2. But where will those 2 values be? If there's 18 students, then the 2 median values will be found in the 18 divided by 2 position, so the 9th position, and then 9 plus 1, the 10th position. So where are we finding this 9th and 10th number? And here's where this can get a little, well, as if it wasn't already weird. It can get a little weird here. So to find where the 9th and 10th students are when we put these numbers in order, remember that there are 2 with 24 and there are 4 with 25. So far we have 1, 2, 3, 4, 5, 6 students accounted for. If I am to write out all 8 26s, I will find the 9th and 10th students, right? So 26, 3, 4, 5, 6, 7, and 8. So now I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 and 10. So I know the median is going to be 26. And again, if you just write these numbers out, you will find that you end up with 26. So the median is 26. And what about the mode? So when we're given the frequencies, we're looking for the largest frequency because that's the score that the most students scored. So the largest frequency is 8. And it turns out now 8 is not the mode. 8 was the frequency. That's the number of students who got the mode. What is the mode? It's the score associated with 8. The mode is 26. This was a very, very consistent problem. So looking at when we have a frequency table, it was just a coincidence that everything ended up being the same, but we found the mean score to be a 26. We found the median score to be a 26, and we found the mode to be a 26. These have been examples of calculating the measures of central tendency. Thank you for stopping by.